Anyways, today we're going to be proving triangle congruence with side, 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 and side, angle, side. Now, from pre-algebra, I didn't do this in algebra class, but in pre-algebra we did it a little bit. But we need to note what congruent means. Congruent means that the shapes are the same. So that's the first thing. You have to have the same shape. And not only are those shapes the same, their side lengths are the same. And the angle lengths are the same, or the angle measures. It's not really a length, right? The angle measures are the same. Okay, so what is side, side, side? Now we're going to talk specifically about triangles. Side, side, side. That's what that means. Side, side, side. Side, side, side. Meaning, all the sides of two triangles are congruent. So if we have side, 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 we would say if our triangles are congruent, if we can show three sides congruent. So you'd have your two triangles, and if I can show each of these sides, then I have proven this triangles are congruent without involving the angles at all. So I would need to show that AB is congruent to DE, and I need to show that BC is congruent to EF, and I need to show that AC is congruent to DF. If I show that, I can therefore conclude triangle ABC is congruent to triangle DEF, or whatever the letters happen to be. So now we're going to do one proof. It'll be a short proof. Some of these triangle proofs really are really short, but you need to be careful how you identify your side, 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 or your side, angle, side, which we'll get to in a moment. I'll give you a second to finish writing all that.
Okay.
Alright, going on. Okay, here's our diagram. Again, when we write our congruent statements, the congruent parts, the congruent segments and angles need to line up. So A corresponds with A, B corresponds with D, and C corresponds with itself. So we have some statements, reasons. This is going to be a really short proof, really simple. Statement 1, usually we will start with the givens, and I'll go ahead and do both of them in the same thing. Now you really are going to want to use your diagrams. So copy diagrams from the book into your homework so that you can write on them. Don't be writing in your book. Alright, watch the thinking and then we'll formulate the proof. I'm going to mark my diagram with a given. So I have AB is congruent to AD. See how I marked that? And I have BC is congruent to DC. So I marked it with two hashes. So I see, as I look at these two triangles, I have two of the three sides. But notice they share a side, don't they?
Yes.
Okay, so that's going to form my next thing. This would be the third side that I need to show. And that's pretty simple. Segment AC is congruent to segment AC. Who remembers something equal to itself? What that is?
Oh, reflexive?
Yes, that's the reflexive property. Something equal. That comes up a lot. Something equal to itself. So when I'm doing my diagram, I might write on one of the triangles, I have a side, I have a side, I have a side. So this is proof by side, side, side. So triangle ABC is congruent to triangle ADC by side, side, side. And I'm done. Yay. Our first triangle proof.
Please leave it up there. Are they always going to be this easy?
No. Alright. That's our first one. And there, I mean, very few proofs except for like this section are actually just going to be side, side, side. Usually you have to get some angles involved, which is why we have the next one. Okay, so the next one is side, angle, side. And what we mean here is that the angle is included. It's an included angle. So as I take a look at this, take a look at my diagram here, this is an included angle. Meaning it's between two things I know. Okay? It's between, so I have a side, I have my angle, and I have my side. The angle is included. It's between two other things that I know are congruent. So triangles are congruent if we show two sides and their included angle are congruent. So if I can get a side, an angle, and then the next side, in any triangle, any pair of triangles, then I have proven that those triangles are the same. So we'll do two proofs that involve this. Just because I know how much fun you're going to have with this. Yay.
You mean how much
Is
fun
that
you're
a
going to have? Or
them or them?
what is
That's a there.
Use some context clues to read my writing. And there, as in those triangles, if their included angles, if their included angle are congruent, as in their sides, the angle between their sides. Anyways, all right, here's our diagram. Given segment EK is congruent to segment AK, and segment DK is congruent to segment BK, we are going to prove triangle AKB is congruent to triangle EKD. Again, we got to be careful of the order that we write those vertices. They have to line up the corresponding parts. So we have our statements, we have our reasons, and let's inspect our diagram. So look up so that you're seeing. I have two sides, right? So I have my side, and I have these two sides, right? So I have a side. What do we know about these two angles?
Vertical.
They're vertical, therefore they are
Equal.
So side, angle, side. We have just thought through the proof. Use the diagram and mark it to help you think through the proof of how this should go. So statement 1 is going to be our givens. So EK is congruent to AK. Now, you do not have to do what I'm about to do. You could give all your givens right away. But I'm going to give 1, there's my side. Statement 2, I'm going to say angle, which angle is this?
DK.
DKE is congruent to what other angle?
AKB.
AK, well, I want to BKA.
Okay.
Just be precise with my angle naming. So that's my angle, right? And those are congruent because vertical angles are congruent. All right, so those are vertical angles. I have my angle. I might mark my diagram with an angle there, and then I'll take my other given. DK is congruent to BK, Burger King. And that's given. So I have my side, side angle side. So statement 4, triangle AKB is congruent to triangle EKD. By proof by side angle side. Now, I like doing it that way just so I see that, but be careful. Okay? Angle. What if I did where I listed my givens first? I'd have a side, and an angle. That's not one of our things, right? So, reason from your diagram. I have a side, I have the angle, and then I have the side. You see what I'm saying?
Yes.
I have one person who sees what I'm saying.
Yes,
The order I write my statements might not be the order that I say. They might be in a different order than that actually appears in the diagram, is what I'm getting at. It needs to be based upon the actual physical location in the diagram. Side, angle, side. Also, there's no such thing as side, angle, anyways. Well, I mean, it doesn't prove anything, but... Okay, let's do another proof. Let's take it a step further. Given. And then that's pretty much it for notes. So given, D is midpoint of segment AC. Angle ADB and angle CDB are right. Prove triangle ADB is congruent to triangle CDB. Yeah, we'll do one more proof after this.
Do you like proofs?
Yeah, proofs are fun. gotta think through it. This is logic, guys. You gotta think through, just not assume things.
We love to assume.
Yeah, I know, and usually your assumptions are wrong.
Well, that's generous.
Okay, statements and reasons. Let's think through. It's always good before you try to get like your undies in a bunch down here with the statements and reasons to look at your diagram and think about what's going on. So I have D is the midpoint of AC. So if D is in the middle of AC, what do we know about
And
those?
D is your equal.
AD and CD are congruent.
Correct.
And I have two right angles, so what do we know about those?
Those are equal. Those two.
And then we have this side shared by them, so we know we have that side. So we have side, angle, side. So this time I'll just do I'll just put the first given here. D is midpoint of segment AC. And the reason I say that is because it's given. It's something that we know. And I'm going to reason something off of this given. I like to deduce things rather than just list my givens. So I'm going to deduce something from this given. I'm going to deduce that AD is congruent to
CD.
CD because
lines intersected with the midpoint are equal or
Definition of
congruent.
midpoint.
definition of midpoint. Daniel was giving us a nice
I
one.
know.
It was a beautiful sentence, well written.
Stephanie.
Those of you who end up taking, because you're doing engineering or something math and you have to do these proofs, you actually don't do them in 2-column proofs, you do them in paragraphs. You have to reason, like, I legit, one of my math geometry tests were 2 proofs. It was just 2 proofs, and both questions took an entire page, writing the proof out. It was like, it's so hard. But it's it's a lot of language and a lot of logic and a lot of like showing why you say certain things. So, you know, but it's still the same kind of thinking. All right, so we have this, and so now we have a side, right? So I might write side right here. Now I'm going to say angle ADB and angle CDB are right. And the reason I can say that is because it's given. And again, you could just list all your givens and write your other statements later. The order really doesn't matter. I just like being logical in the thinking. So because these are right angles, what do we know about them?
They're equal.
They're equal. See, I am deducing something from that.
What do you mean by deduce?
I form a conclusion.
Okay.
Alright, so because they're right angles, I say that they're congruent, and this is one of our things that we had a while ago. All right angles are congruent. That's one of our things. Which, by the way, I noticed in the back of many of your guys' notes, you don't have all those statements. You are going to be very sad this chapter that you do not have that.
I have them in the front, Kane.
Oh, well, some of you are...
I got them right here.
Like, you gave a bunch of people A's.
Because their notes weren't very good.
What do you want us to do?
Be perfect children.
Alright, Jesus.
Hey. Okay, close. Alright, so I have all right angles. How do I get BD?
BD.
Segment BD is congruent to segment BD. Why?
Because, reflexive.
Yeah, something equals itself. Reflexive property. Now, let's say you're a bonobo and you forget this word.
Lines are equal. Same lines are equal to themselves.
No, something equals itself. Right? Something is equal to itself. You could write that. You could write the definition of reflect. I think it's easier to just remember reflexive means something equals itself. But if you forget that word, you could write something is equal to itself. Alright, so statement 6, triangle ADB is congruent to triangle CDB because... Why?
No.
It is not given.
Side angle side.
Side,
Oh, we have
angle,
to prove
side.
that.
If it were given, I'd have nothing to prove.
Oh, I was looking at the proof on my paper, and I thought this said.
And now we're happy because we have done our proof.
Can we not do another one? Because I don't do nothing.
No, we're doing one more.
Ugh.
So which one would be the angle one that you solved? The number 3 would be the angle one?
Don't do it, baby.
Hold on. Quiet your yips down. Okay. One more. Getting this down, you should be writing your diagram. You have any issues in here? Yes.
Oh, I just got it out.
Segment A, B.
Here, I'll go.
I don't care what you want to do.
You're right.
Okay, there's our givens. We're going to prove triangle ABC is congruent to triangle CDA.
We ever have like 2 proofs or something? Is that impossible? Like we had to prove like 2 things in one.
Sometimes you have to prove one thing in order to lead to another thing. Okay, let's think about this. I've given AB is parallel to CD, so I'll mark that with a little arrow. These are parallel, but not only are they parallel, they are
Equal.
they're congruent, they're equal. So I do have a side right away. What does that make this line right here?
Perfectly. Well, we don't know that it bisects. So because
It doesn't bisect anything, but if these lines are parallel, that makes this a transversal.
yeah.
Which means, what about this angle and this angle?
They're equal.
Because of what?
Alternate interior angles.
Right. We have alternate interior angles.
We're
So those
combining
are-
old stuff.
Huh?
We're combining old stuff with it.
Exactly. So, statement 1. I'm going to start with segment AB is parallel to segment CD. That's given. And from that, I'm going to reason that angle BAC is congruent to angle DCA because, what was the reason?
Because alternate interior angles.
Alternate interior angles are congruent. Alright, so I have alternate interior angles. Then I also have segment AB is congruent to segment CD because of given. So I have a side, I have an angle. Where is my next thing?
Find another side.
I need another side. What's the other side?
CD. Oh, DC.
Yeah, BC.
I don't. How would I get BC?
I don't know. Something.
I don't know that BC and AD are congruent.
Well, we know.
And even if it did, it wouldn't help me. That would give me side angle.
we know that DC.
Oh, side angles. So we need something on the other.
CD is congruent to AB.
That's what he had.
Hello, they share a side. Do you see they share a side?
So AC is equal to AC. Or
AC is congruent to what?
AC.
AC
Reflective.
by reflexive. Reflexive comes up a lot. So now I have side angle side. Listen, here's how you know you were going down the wrong route by thinking about BC. You would have had a side right here. You see what I'm saying? You would have had side angle. But that's not one of our things. We have side, 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 and side, angle, side. So you know that's the wrong route. Alright, so we have proof by triangle ABC is congruent to triangle CDA by side, angle, side.
What if you left out the angle and just used side, side, side?
Okay, but again, I don't have a way to get BC congruent to AB. I mean, what reason do you have for that? Now, I could prove that right now. I could say, alright, the triangles are congruent, so therefore all their parts are congruent, right?
Right.
And now I could say, which is actually a proof that we'll do at the end of the chapter, where we first prove the triangles are congruent, and then we prove that their different parts are congruent. But for now, we're just proving that the triangles themselves are congruent. Justin, you should be paying attention.
I have, but I've written every single note
Dude, I
down.
can see your face from back here. Okay. Anyways,